When an AI agent fails, we usually blame the model. Maybe it needs a better prompt, more parameters, a newer model. But the model is only the engine. Tools, memory, context, and evaluation determine what that engine can actually do. So the real question isn't how smart is the model, it's what have we built around it. And that's where prompt engineering becomes something much bigger. Prompt engineering optimizes one interaction, but an agent doesn't make just one decision. It observes, acts, gets feedback, and acts again. Reliability comes from the whole system: model, context, tools, constraints, and feedback. That's the shift to harness engineering. So, what exactly is a harness? The harness is everything around the model that controls how it operates. What can it see? How can it act? How does it verify its work? When should it retry or stop? Change those rules, and the same model can behave like a completely different agent because the model itself is only one part of the machine. A model alone doesn't have tools, memory, permissions, or a reliable definition of success. All of that comes from the surrounding system. The model proposes an action, the harness decides what it can see, what it's allowed to do, and whether the result actually counts. And this is exactly why better prompts eventually hit a ceiling. A great instruction can't fix a broken environment. Given an agent stale context, dangerous tools, no feedback, and no stopping condition, and a longer prompt won't save it. A strong harness fixes the system instead. Relevant context, scope tools, sandboxed execution, verification before completion, traces when something fails. The goal isn't zero failure. It's making failure visible and recoverable. And that requires a loop. Reliable agents shouldn't be one-shot generators. They should operate in a closed loop. First observe, get the information needed right now. Then act, use a tool and change something. Then verify. Did that actually work? If not, adapt. Use the failure as new information, revise the approach, and go again. That's how you engineer toward an outcome instead of hoping for one. In practice, this loop has three major layers. First, context, what can the agent see? Second, execution, what can it actually do? Third, verification, how does the system know whether it worked? Most agent failures come back to one of these three layers. Let's start with context because more isn't always better. Don't give the agent everything, give it what matters. Dumping an entire repository or massive history into context creates noise. Important information gets buried. Instead, start with the task, retrieve what's relevant, make the decision, and update context as the task evolves. Progressive disclosure, just in time retrieval, compaction, persistent memory. The goal isn't maximum context, it's maximum relevance. Once the agent knows what it needs, we have to control what it can do. Tools turn generated tokens into real-world actions, so tools design matters. Giving an agent unrestricted shell access, arbitrary file writes, or direct production deployment is powerful but fragile. The system should enforce policy outside the model. Use least privilege, structured inputs, sandboxes, reversible actions, full traces. A good tool makes the correct action easy and the catastrophic action difficult. But even a safe action can still be wrong. Never use "the model says it's done" as your definition of code or the definition of code completion. The agent makes a change, then the system tests it. If the test fails, that's not the end, that's feedback. Diagnose, revise, test again. The agent stops when an external condition passes, not when it generates a confident sentence saying everything worked. Here's what that looks like in the real coding workflow. Task: add rate limiting to an API. A weak agent might immediately start writing code. A better system first inspects the code base and finds the existing architecture. Then it plans the change, files, tests, constraints. It edits inside a sandbox and run targeted tests, linting, and type checks. Finally, it reviews the diff, checks for regressions, and only then opens the pull request. Same task, very different trajectory. And here's the important part. The model never changed. A weak harness guesses, edits, and hopes. A strong harness inspects, acts, verifies, and iterates. The model doesn't need to be perfect on attempt 1. The system needs to catch and correct imperfect attempts. But faster agents create a new problem. Agents can generate code faster. They can also generate technical debt faster. Small inconsistencies accumulate, patterns get duplicated, conventions drift. Eventually, the repository becomes harder for both humans and agents to understand. So architectures, rules, dependency boundaries, cleanup, and living documentation need to become part of the harness. Because if the agent degrades its own environment, every future run gets harder. And you can't fix that if you only look at the final output. A failed result tells you that something went wrong. A trace tells you why. What did the agent receive? Which tools did it call and why? How did the state change? Where did the trajectory break? If you can trace the full run, failures become engineering data. And improving those trajectories can create a massive difference in real world completion rates. Two agents can sound equally intelligent and perform completely differently. A thin setup may fail repeatedly on long multiple stepped tasks. Engineering the context, tools and verification and completion can improve dramatically. These numbers can be illustrative, but the principle matters. Sometimes the harness is a bigger upgrade than the next model, especially because the harness can keep improving. The model can stay exactly the same while the system gets better. A failure trace reveals a weakness. That weakness becomes a better tool, a new context, a stronger check, or a new policy, and the next run improves. That's why the system matters more than one clever prompt. Prompts don't compound very well, infrastructure does. So, where should you start? Don't begin by designing the perfect agent architecture. Begin with real failures. What actually went wrong? Missing context, unsafe action, bad plan, no feedback, endless loop. Then encode the repeated correction into the system, not into an even longer prompt. Run again. Measure the full trajectory. Keep what improves outcomes. That's how a harness evolves. And it leads to one final principle. Models will keep getting smarter, but intelligence alone doesn't create reliability. The real goal is to make the entire system harder to fail. Better context, safer execution, real verification, full observability, continuous evaluation. Don't treat the model as the entire product. Build the environment that let its intelligent actually work. That's the shift from using agents to engineering them. That's so next time you are building an AI agent, don't just ask which model should I use. Ask what system am I building around it because better agents don't just need smarter models, they need better harnesses. Thank you for watching and I'll see you in the next one.